Okay, here we talk about square roots, the parts of the square root. This is called the index, where the n is at. When we see a square root, normally there's nothing written there, but this could have a 3 here. That means that's taken to the third root. We could have a 4, 5, or whatever number up there. This is the radicand, which is the number that is inside the radical, and then again we have the radical sign here. Now, on a typical square root, we normally write it like this, the square root of x. There is normally a 2 up in the index. It is not written there because, again, it's something that we use so often that we don't normally write the 2 up there. So, again, if it's written like this, it's the same thing as this. Okay? So, normally when we have a square root of something that is a perfect square, what happens is that the square root undoes that square because it's the very opposite of that. So normally we would have the index number of a 2 written right there. What happens is that the square root cancels with the perfect square so that it undoes it, and we get the value that is inside, the radicand that comes outside. So normally what happens is when we have that, we think about perfect squares and how we get perfect squares. Now either that number could have been positive or it could have been negative. So when you take a square root of something, you normally would get a positive value or a negative value. For example, if I have the square root of 4, we think about that, what numbers multiplied by themselves will give us 4? Well, if I have a positive 2 times a positive 2, that will give me a positive 4. And if I have a negative 2 times a negative 2, that will also give me a positive 4. So anytime you take the square root of a number, there's a possibility of getting a positive or a negative value. But for this case, or for this chapter, we only will assume the positive value. So right now, square root of 4 is only a positive 2, not a positive 2 and a negative 2. This will be coming in more, I think, in chapter 8, where we'll be considering both values, the positive and the negative. So looking at some examples, we have the negative square root of 4. Well, since the square root of 4 is 2, the negative 1 that is out front just slips down, and these will be multiplied together because really this is a negative 1 times the square root of 4. So a negative 1 times 2 would give us a negative 2. Now in this case right here, the square root of a negative 4. If we think about this, we have to ask ourselves, what times itself will give me a negative 4? Well, 2 times 2 will give me 4. And a negative 2 times a negative 2 will give me 4. But there is nothing that will multiply itself to give me a negative 4. That we call is a does not exist solution. You can put D-N-E for does not exist. In this case, anytime you have something that is negative inside of a square root, you cannot find a solution for that. Because anytime you have a negative inside the square root, those are called imaginary numbers, and that is a different type of math that we do not go over in this class. So again, no negatives inside the square roots. Negatives on the outside of the square roots are okay, but no negatives on the inside of the square roots. Okay, I want to talk about the graph of a square root. So we have a function that equals the square root of x. Here we see that we have x such that x is greater than or equal to 0. So again, we can't have negative values inside the square root, so we have to use positive values, and that's what this says right here. That x could be 0, because the square root of 0, it would be 0. And we could use 1 and so on and so forth, and the graph will look like this. Now typically, if we were taking into consideration that we could get a positive or a negative value from taking the square root of, let's say, 4, there would be an identical curve underneath this one right here that would go with this graph. But because we're only considering positive square roots, we're only going to have this top curve right here. Okay. So if I give you a function, let's say f of x equals the square root of 7x plus 4, and I want you to find f of 3. So again, what we have to do here is just substitute 3 in for x. So I get the square root of 7 times 3 plus 4, and that will equal the square root of 21 plus 4, which equals the square root of 25, and that is going to give us 5, positive 5. Now again, this, if we were in chapter 8, this would be a positive and a negative 5, but for this sake, in chapter 7, we're only going to use the positive 5. Next, we're going to talk about cube roots. So again, we see that the index changes to a 3 cube, meaning to the third power, and we have a number inside. That means that we need to find out what times itself 3 times will give us this number. So that means that if I were to undo this, that means that b to the third power would equal our radicand inside. So for example, if I have the cube root of 8, so I need to know what times itself will give us 8, and that would be 2. Okay, so we have a function here, g of x equals the cube root of 13r. Okay, we have this function here, g of x equals the cubic root of 13r plus 1. I want you to find g of 3, so that means substitute 3 in for our variable. Sorry about that, this should be an r. So we substitute that in for r, so we get the cube root of 13 times 3 plus 1, which is 39 plus 1, which is 40. So what we need to do is get our calculators out and calculate the value of this. So depending on what type of calculator you have, here I have a mock of the TI-83. Now you're not going to find it here, you're going to have to go under the math button, which is under your alpha button. I don't know if you can see that, it's going to be a little bit hard, but down on the 4th option, it does have the option to take the cubic root. So it'll look like this, 4, and then it'll have the index of 3, and then the root, and then a parenthesis. So that is going to how you're going to stick that into your calculator on a TI-83. Depending on what type of calculator you have, we might need to look at the specific type of calculator to figure that out on how you're going to do the cubic root on your calculator. If you have a question on the calculator you have, take a picture of it and email it to me, and then I can better help you on how to do that in your calculator. So when we stick that into our calculator, you'll get a number like this. Again, in my math lab, it'll tell you how many decimal places to round it to. Usually 2 decimal places is about right, so we could say that that's approximately 3.42. Okay, next we go over even and odd roots. So here we see the 4th root of 16. Now remember, since it's an even power, that's the same thing as like our square root of 2. There has to be an even number of signs in order for us to get a positive. So that means that we're not allowed to have a negative inside the radical. So that means that we have 2 here. So that means 2 times 2 is 4, times 2 is 8, times 2 is 16. So something that is multiplied by itself 4 times to get 16, so that would be 2. Okay. Now down here again we see the square root, or the 4th root, excuse me, of a negative 256. That means again this is a does not exist because that negative on the inside. But when we come over to an odd root, we see here the cubic root of a negative 27, and that's okay to have it in an odd root. So negatives inside of an odd root are okay. Negatives inside of an even root, not okay. So we have negative 3 here because negative 3 times a negative 3 is a positive 9, and another negative 3 will give us a negative 27. So again, you will get a negative if you have an odd root and also a negative on the inside of the radical. Okay, radicals and absolute values here. Anytime you take the square root of a perfect square or a perfect square, yes, you get an absolute value of a, and that's just for this chapter. So when we take the square root of 4, we're going to get a positive 4, meaning that when we take this, we're going to get a positive answer. Okay, so for example, if I have the square root of 25 squared, now remember, square roots and squares are opposites of each other. So therefore what's going to happen is that this square root and this square are going to cancel each other out to give us 25. Now, you could multiply these out, but it's not needed, because if you understand that the square root is the opposite of a square, then you're okay. Now, 25 squared means 25 times 25, and perfect squares, again, take out perfect sets like these. So the square root of 4 is 2 times 2, so that's why a 2 comes out. So here we see a perfect pair of 25s here. That square root right here is going to take that perfect pair and bring out just 1 here. Okay, same thing can be said for here. If I have the square root of a parentheses 13.9 to the second power, that square root and that square will cancel each other out, and we just get 13.9. Okay. Now, something very similar to that is that I have the square root of 5 being squared. So remember, the square root and the square cancel each other out, and the 5 is our answer. Same thing here. If I have the square root of 4.5 being raised to the second power, that square and that square root are going to cancel each other out, and we're going to get a positive 4.5. Continuing on with the perfect squares equaling an absolute value. If you're given something like this, a square root of the quantity x plus 5 squared, we have the same effect as what we saw before, that the square root and the square will end up canceling each other out. But you have to be careful with the way that you write this. Now, the square root and the square will cancel each other out to give us x plus 5. But we have to be careful with this because we need to make sure that this entire thing, depending on what number we stick in here, will always be a positive. So that means that we have to put absolute values around here. Now, this could be written without the parentheses as the absolute value of x plus 5, because remember, anything that we stick in for x, this entire thing, your answer, needs to be a positive, because remember, when we substitute a value in for the square root, we need to get a positive out. So this will guarantee that we get a positive value out. If we did not have the absolute value bars here, when we graphed this, we would get something like this, which, again, when we talked about the graph of a function or something that had a radical, we would only want the top part. But without the absolute values, we would only get both the top and the bottom part, and that's not what we want. So with the absolute values, that will ensure that we're only getting the top part of this curve, which is what we want for this chapter. Okay. For example, if we had something like this, where we had the square root of a squared minus 8a plus 16, so we have to go back to chapter 5 and 6, which requires us to factor this. Now remember that this 16 is a perfect square, so you should be thinking the square root of 16 is 4. So when we factor this, we're going to get x minus 4 times x minus 4, which is the same thing as the square root of x minus 4 squared. Okay? So again, the square root and the square end up canceling each other out, but when I bring everything down, you need to make sure to use absolute values on that. Now, this is only because we are working with square roots. If we did this using a cubic root, if I gave you a cubic function underneath that, we wouldn't have to worry about the absolute values, because again, it's okay to have negative answers with our absolute values, our negative answers with our cubic functions.